We can go ahead and formally start the BC Lung Health Air Quality webinar for today. Before we do start, I want to acknowledge that we are on the traditional, or we are in the traditional unceded territories of the Musqueam, Squamish, and Tsleil-Waututh Nation here in Vancouver, British Columbia. I just want to acknowledge that and say I'm really honored to be here. So let's go ahead and get started. We have an important talk today from Naman Paul. This BC air quality webinar is brought to you from the BC Lung Foundation. My name is Eric Coker. I am with the British Columbia Center for Disease Control. And I work as a senior scientist here, a lot of work in air quality, and in particular wildfire smoke. But we have a really important talk from Naman Paul today, who I will introduce in just a moment. Before he gives his talk, I do want to mention that the BC Lung Health Foundation Air Quality Workshop, which happens every year, we do have it scheduled. So that right now it's scheduled for March 12th. So they'll be primarily in person, but I believe there will be an online option. Suffice it to say, please look out for an email announcement coming out for a save the date for March 12th for the BC Lung Foundation Air Quality Workshop, the annual workshop. So now I'm really pleased to introduce Naman Paul to give a talk today. Naman is a data scientist for Environmental Health Services here at the BC CDC. He's been working here for about 4 years. He describes himself as a data nerd and he has a lot of experience with computational chemistry, computer-aided drug discovery, and machine learning and computation. He holds a Master of Science in Bioinformatics from UBC, as well as a Bachelor's in Bioinformatics from Amity University in Rajasthan, India. His current work involves the development of statistical and machine learning models to estimate biomass smoke exposure across Canada. He has worked on analyzing extreme heat temperatures, as well as upgrading the BC asthma prediction system, commonly referred to as BCAPS. So Naman brings a lot of experience in developing these machine learning models, and this talk today will be on identifying Canadian communities disproportionately impacted by long-term biomass smoke exposure using CanAwesome, with a little bit of a special emphasis on BC population. So Naman, I'll hand the mic off to you.
Perfect. Thank you. Thanks a lot, Eric. And thanks a lot for the BC Lung Foundation for giving me this opportunity. And again, so I would just like to reiterate the title of the talk for today, which is Identifying Canadian Communities Disproportionately Impacted by Long-Term Biomass Smoke using CanAwesome, which is the acronym for the Canadian Optimized Statistical Smoke Exposure Model. Before I begin, I would like to acknowledge that the land on which I work, play, and live is the traditional, ancestral, unceded, and occupied territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, and Tsleil-Waututh nations. And today I'm joining from my home in Coquitlam First Nation, also known as Coquitlam. Here's an outline of what I would like to go over today. I would provide a quick background about what CanAwesome is, its applications that have been carried out so far, the performance of the model, which is exhibited by a case study. I can just show those for you quickly, and the identification of communities that have been exposed to higher concentrations of biomass smoke in different Canadian regions and different seasons. I would also highlight a few communities that have been exposed to prolonged biomass smoke, and residential wood smoke being the most important out of those. And I'll wrap it up with what's in the store for CanAwesome as we move forward. Here's a contrast of a clear day at the University of British Columbia Rose Garden versus a smoky day as a result of wildfire smoke. And out of all ambient air pollutants, PM2.5 is most elevated by biomass smoke and is also one of the air pollutants that is routinely monitored and can be used as a proxy to study air pollution. As we all know, biomass smoke is intermittent, highly unpredictable, episodic, and dynamic. Wildfire smoke can also travel large distances. This is one gift that I obtained from Copernicus in Europe, and it shows the California wildfire of 2020, which being one such example when the smoke made its way up north into BC, continued to drift across Canada, crossing the Atlantic Ocean and reaching Europe. And this one, which I recently updated, is from 2023. This is from June 2023, when huge smoke plumes made their way across the Atlantic into Europe, given the unprecedented early wildfire season that we had in Canada. Why do we need a smoke exposure model or a new smoke exposure model? The first reason being it is challenging and very expensive to create ground monitoring stations everywhere. And given how sparsely Canada is populated, we cannot just have ground monitoring stations everywhere in the country. The fine particles in the smoke can be a serious risk to public health. Many populations are repeatedly exposed to smoke during the wildfire season as well as the residential wood heating season. Hence, it's important to study both the short and the long-term effects of smoke exposure, not only in those locations where we have ground monitoring capabilities, but also the populations which are living in remote locations. Daily or hourly models are usually required to capture the spatiotemporal variability in contrast to traffic or industrial patterns where we know the annual, seasonal, or monthly models can be sufficient because the pattern overall remains the same. One of the biggest motivations for this particular project was previous work done by Dr. Angela Yao at the BC CDC, who developed the BC Awesome, the British Columbia Optimized Statistical Smoke Exposure Model, which has been operationalized for public health surveillance since 2012. And PM2.5 estimates generated by that model have been successfully used to analyze health outcomes and inform decisions. Like I said, the air quality monitoring stations, these are the 300 stations that are established under National Air Pollution Surveillance Program. And these are spread across rural and urban areas and measure pollutants such as nitrogen oxides, ozone, and most importantly, in our case, the fine particulate matter. So this is what CanAwesome looks like, or the Canadian Optimized Statistical Smoke Exposure Model. Here's a snapshot of the spatial raster that we have used to develop this model that predicts daily mean PM2.5 concentration across all populated regions of Canada, which have been shown here in gray, which were at a 5 kilometer by 5 kilometer spatial resolution, but originally a 10-year period between 2010 and 2019, which we have now extended up to 2022. CanAwesome integrates data from multiple sources, and these are the kind of sources that we have looked at. It's a whole variety that we are using. We are looking at the daily smoke plumes that were retrieved from the hazard mapping system produced by NOAA, the locations of wildfires detected by MODIS satellite systems, and their fire radiative power, basically how bright a fire is burning. We also included a bunch of meteorological parameters such as temperature, humidity, wind speed, wind direction. And these we obtained using the MERA, or the Modern Era Retrospective Reanalysis product that is also produced by NASA. And we have also used the aerosol optical depth, which basically quantifies the light extinction in the atmospheric column by aerosol particles such as dust, smoke, and pollution. For our response variable, which is what we are trying to model, we have used the PM2.5, hourly PM2.5 measurements for each day during the entire study period, and then we averaged it to 24 hours. This basically leads us to a big data set For the 2010 to 2019 period, this was 481 million data rows, out of which only 18 million data rows were complete, which we then stratified into different prediction, training, and validation sets. We used the ranger package in R to develop the random forest model. And like any real life data sets, we did face the challenge of data missingness. And one of those components was the modest aerosol optical depth, which is very sensitive to presence of clouds, or if the smoke plumes are too thick and actually nothing can penetrate that. So we decided to train another model, which is called the secondary can awesome model. This was trained using all parameters except the modest AOD data. And what the main goal that we wanted to do was to look at how well this model is performing, and we could validate it against the measured concentrations. So here on the y-axis is the difference between predicted daily mean and observed PM2.5 concentration. So it's a subtraction. And on the x-axis, we have the timeline. We have the time series from 2010 over 2020. So the more of these points are concentrated closer to the zero line, meaning that there's no difference or between the observed and the predicted, it highlights less of a discrepancy between the predicted and the observed PM2.5 concentrations. So the model performs well overall. However, really smoky conditions, which were the outliers, could not be accurately quantified. One of these include the Fort McMurray interface fire of 2016 and the 2017 and 2018 BC wildfire seasons. When we look at what all variables, what role did they play in the model, we calculated it using a permutation mode while generating the random forest model itself. And notably so, the top 5 variables that we have here came from 5 different data sources. So we had the surface specific humidity, the FRP daily sum, the AOD at different wavelengths, and the HMS smoke plume presence. This is an interesting finding which highlights the confluence of multiple factors that may result in higher PM2.5 concentration in the air. So jumping right into one of the case studies that we performed while developing this model is a study at Burns Lake, British Columbia. This is a region that was in a very close proximity of the wildfires burning in August of 2018. And here we have the can awesome predicted PM2.5 concentrations on the y-axis, which are colored according to the model that predicted it. So the red ones are predicted by primary can awesome, the blue ones are predicted by secondary can awesome. And the black line on top basically represents the NAP's observed daily mean PM2.5. So those were the ground-based measurements. And this shows a period between December 2017 to December 2018. You see this huge sharp peak for August 21st, 2018. And it was to such an excess that we had to basically cut off our y-axis and then have that posted up there. When we visualize the same day here using a map, and there were communities along the Yellowhead Highway which were severely impacted by the smoke. Towns such as Prince George, located further here, would go on to have about 32 days with poor air quality and air quality health index values which were in the unhealthy range for a long period of time. In addition to the wildfires burning in the northwest, there were wildfires burning in the southern interior of BC as well. Which brings us to the applications of can awesome estimates. The very first thing is all of the estimates PM2.5 estimates that we have generated using can awesome are publicly hosted and publicly available on Canoe, which is the Canadian for the urban environment. I'm forgetting the word, the acronym for the A, but all of these estimates are available publicly and they can be downloaded. What the studies have been used, so the estimates have been used so far. One of the master's student under Dr. Sarah Henderson incorporated these estimates to assess the in utero exposure to wildfire smoke. They have also been used to study salbutamol dispensations during wildfire events. And salbutamol is a drug that is used for managing asthma. Uh, these estimates are also being used to study the relationship between biomass smoke exposure and COVID-19, as well as to study the cost effectiveness of HEPA air purifiers for preventing wildfire-related asthma complications. So the model estimates have already been put to use. This was basically a very quick summary of CanAwesome, which was almost 2.5 years of work. The next thing, then in the next round of funding, what we did was to introduce a couple of improvements that we recognized were missing out. The very first one that was to enhance the spatial coverage. Originally, we were using the NASA gridded population of the world data to recognize locations along our gigantic spatial raster of where the populations actually reside. Doing so, we did miss a couple of remote population locations. So we did a comprehensive analysis using NASA's Black Marble product to look at the night lights and looking at all of those components put together. So we added about 63,000 raster cells to our existing populated raster cell count. And other than that, we also retrained the model using the data from 2020 all the way to 2022. And it's really important that tools and models such as CanAwesome need to be retrained over time as new data become available, or especially after a big wildfire season. All right, so jumping right in, the CCME, or the Canadian Council of Ministers of the Environment, have established the Federal Air Quality Standards, or also known as the CAPs. And the latest ones that we are referring to is from the year 2020. The 24-hour air quality is based on the 3-year average of the annual 98th percentile of the 24 average concentrations, which is currently set at 27 micrograms per cubic meter, whereas the one for the annual scale is currently set at 8.8 micrograms per cubic meter. Whereas when we look at the British Columbia air quality objective, that is more stringent, that were adopted in the year 2009. And for BC, the 24-hour PM 2.5 objective is currently at 25 micrograms, and for the annual is at 8.0 micrograms per cubic meter. So jumping right into the results of when we use these thresholds, we observed an increasing trend of the number of raster cells being exposed to high PM 2.5 concentration annually, which are above the annual PM 2.5 federal guideline of 8.8 micrograms per cubic meter. So on the y-axis, again, we have the number of populated raster cells that were exposed annually to an exceedance of 8.8 micrograms per cubic meter concentration. So, and on the x-axis, you have the entire time series. So in 2010, whereas we had just about 3,000 cells that were exposed, this has substantially increased over the 13-year period from 13,900 cells to about 25,000 populated raster cells in 2021. It should be noted that we have not yet trained the model using the 2023 data, and we can take a moment to imagine how this particular chart is going to look like the moment we throw in the 2023 data in. And honestly, I won't be surprised if we need to rescale the 2020 the entire plot, because the y-axis is probably going to hit a very, very high number. So defining the high biomass smoke exposure. So we used a particular criterion to define high biomass smoke exposure. So it was a simple criterion whether a populated raster cell was exposed to an exceedance of daily mean PM 2.5 concentration, so within a 24-hour period of 25 micrograms per cubic meter or above. Just to give you a heads up, we'll have a lot of unpublished data and figures that would follow. So just please bear with me as we go forward. So what we are looking here is the cumulative number of days a populated Can-Awesome raster cell was exposed to concentration exceeding 25 micrograms per cubic meter in the last 13 years, that is 2010 to 2022. The color scheme we follow shows a minimum of 10 days of biomass smoke exposure. All indigenous communities here have been shown in pink as pink dots. All the NAPS air monitoring stations have been shown here as black dots. You can see that the smoke is not localized to just southern Canada, but huge swaths of northern Canada as well. Most of the wildfires were in the West Coast and the Prairies region, including and you see these smoke exposures happening in northern Alberta, Saskatchewan, and of course, southern interior and the interior of BC. Also, something which is very critical to note here is about 1,500 populated Can-Awesome raster cells adjacent to the indigenous communities were exposed to high biomass smoke during the wildfire season in the eastern region and eastern Manitoba. And so this is basically the region that was highlighted for us. These include the Poplar Hill First Nation, the McDowell Lake First Nation, and the Little Grand Rapids First Nation in Manitoba. One important thing to note about these is also there are no NAPS air quality monitoring stations nearby for some of these communities, with the nearest station being at least 125 kilometers or 500 kilometers away. Again, this math will look very different when we retrain the model using the 2023 data, which had more number of wildfires burning in Ontario and in Quebec. When we focus on British Columbia, certain regions do stand out in the province. First, with an overall exposure of more than 90 smoky days during this almost 5,000 day period, are the towns of Courtenay and Comox that were exposed to highest number of smoky days on Vancouver Island, communities near Prince George, and in the Thompson Okanagan region also experienced one of the highest number of smoky days in British Columbia. When we zoom in, it becomes evident that several remote communities, including indigenous communities, are disproportionately exposed to high biomass smoke. For instance, the very first one being Inklakapmu First Nation, which is located about 70 kilometers away from the nearest monitoring station. This is located near Ashcroft, and also the Shuswap First Nation in the East Kootenay, which is located about 112 kilometers away from the nearest monitoring station. The sources of biomass smoke in autumn can be highly variable. It could include lingering wildfires. You could have residential wood burning and pile burning or prescribed burning. 3 areas in British Columbia were distinguishable from the rest of the province. The first one being the Berkeley-Nechako region, so area near Vanderhoof, then the in the Thompson Okanagan region, the village of Valemount and surrounding areas, and the central Vancouver Island, including Courtenay Comox and Port Alberni in the Pacific Rim region. Also, please note that the number of autumn days, the scale has changed a bit, but the pattern kind of still holds. When we talk about winter biomass smoke, and I'll go over this once more in great detail as we move forward. So Central Vancouver Island in BC is again was exposed to the highest number of winter biomass smoke days compared to the rest of the province. There were locations near Valemount and Vanderhoof and Fort Fraser, which also experienced high number of winter smoky days. Talking about prolonged biomass smoke exposure. Now, this is very crucial for safeguarding public health and protecting vulnerable populations, mitigating environmental impacts and informing policies, and building community resilience in the face of rapidly changing climate. day-over-day rise or even sustained day-over-day exposure can be hazardous to public health. So we performed two separate analyses. The first one was to investigate the frequency of 3-day long exposures. What does that mean is how many times a particular canosum populated raster cell what was exposed to at least a 3-day long high biomass smoke exposure period. So just kind of looking at how many times what was the frequency of that exposure. Similarly, we repeated this to a 7-day long exposure period. When we look at the 3-day of consecutive high biomass smoke exposure, the locations that were highlighted were located in the BC interior, northern Alberta, Saskatchewan, and a couple of regions of Manitoba, especially the town of Flin Flon, which were highlighted in the higher frequency of these 3-day long exposures. When we made the criterion more stringent, and now what we are looking at week-long or 7 days of consecutive high biomass smoke exposure, the BC interior and the Okanagan region is highlighted again. Also, several Indigenous communities, especially in Alberta and Northwestern Territories, were repeatedly exposed to high biomass smoke over this 13-year period. As we know, the fine particles in the smoke can be a serious risk to health, particularly for children, seniors, and those with heart conditions. We can have a plethora of different impacts depending on the term of exposure, if it's a short-term effect or if it's a long-term effect. And further, a bad wildfire season can also lead to a bad flu season and other respiratory ailments. Recent studies have also suggested that both long-term and short-term exposure to PM 2.5 can affect cognitive performance. Keeping this in mind, let's now look at a few calendar plots. So here is a calendar plot that depicts the dates a particular populated raster cell was exposed to high biomass smoke exposure. And this particular raster cell was located about 40 kilometers away from the nearest monitoring station in Vanderhoof. And I'd like to draw your attention to the color scale, the color legend that we have here, and all the dates that we see, which are highlighted by any color here, were exposed to high biomass smoke. The exposures have, for this particular canosum raster cell, the exposures have not only occurred in wildfire months, but also in autumn and winter months. For instance, in 2012, in 2014, in 2017, and then one period that stands out, which you can clearly see on this particular plot, is the period in 2018. So this particular period, I would like you to look at it from the perspective of starting on July 28th and extending up all the way to September 7th, 2018. So out of these 42 days, 37 days were the community was exposed to high levels of PM 2.5, especially around August 22nd, when the concentration exceeded about 800 micrograms per cubic meter. So whatever dates that you see here, the air quality was pretty bad. When we can look at another example here from the Thompson-Okanagan region between Osoyoos and Penticton. So let's look first at the same period between July 26th, July 27th, all the way until 7th or 8th of September. So you had wildfire surging in Vanderhoof, you had wildfire surging east of Osoyoos, and the drifting wildfire smoke led to poor air quality for almost the same duration. There have been several instances of wildfire smoke exposure in the region, notably so in 2015, 2017, again in 2018, 2020, and 2021. So the repeated biomass smoke exposures are happening in this particular place. One thing we did recognize was when we try to look at the residential wood smoke exposure in the non-summer months, the 25 microgram per cubic meter criterion seems relatively high. So we chose to repeat the non-summer months analysis using the WHO air quality guideline from 2021, which is set for the daily concentration, daily PM 2.5 concentration threshold to be above or equal to 15 micrograms per cubic meter. We also validated our findings against hourly monitored measurements and daily mean surface temperatures. What we figured out was we cannot use a single temperature threshold to say, okay, that's when there was some form of heating that occurred in that community. So we decided to kind of carry out this analysis on a community by community basis. So because the temperatures can vary by a lot just by the season, by the year, as well as within the region and between regions. So it's important to kind of look at these from a community level. So what we are looking at here are the hourly PM 2.5 measurements in the top panel and the daily mean surface temperature in degrees Celsius at the bottom in the lower panel. So this is a heat map that's showing the hourly PM 2.5 measurements that were obtained from NAPS for Valemount, British Columbia, with 2,300 hours on the top, which is going down to 0 hours at the bottom of the y-axis over here. In the lower panel, all of the days or the dates have been sorted based on daily mean surface temperature, which were obtained from NERA. So whatever you are seeing, they are linked. So you have the coldest days on the very left and the warmest days on the very right. Valemount is a village which is located in a deep mountain valley where residential wood smoke often gets trapped at the surface due to temperature inversions. And this village was exposed to high levels of biomass smoke in the period between autumn of 2017 and spring of 2018, which was followed by the wildfire smoke being trapped here in August 2018. So, but we wanted to look at just this particular plot to kind of highlight that. Another thing that I would point out is the hourly PM 2.5 scale. So anything above, so we used 90 as a cutoff. So anything above 90 was just, we kind of made it as a concentration of 90 micrograms per cubic meter, just so we can get a big picture. The examination of the hourly PM 2.5 measurements kind of substantiate the hypotheses that communities are indeed subjected to the influence of biomass smoke throughout the diurnal cycle, a phenomenon that was accurately identified by CanAwesome. PM 2.5 concentrations were the highest during the non-work hours. So here you have this work hour period in which the air quality gets better, partly due to people being at work, partly due to the temperature rising and the smoke basically just lifting up. And the correlation with low temperatures can be clearly seen here as the concentration of PM 2.5 decreased with increasing temperature, pointing towards wood burning and other sources of heat being used in the village. When we look at Courtney, that was previously identified by the work by Chris Hong in 2016 as the second smokiest community in British Columbia during winter. These are one of the highest levels in non-summer months, that people were exposed to on Vancouver Island. And the hourly signals clearly being defined as being elevated overnight. Again, they were relatively lower between 900 hours and 1600 hours during the day, but they kind of increase over time. Something that you would notice is that the temperature pattern is very different. So the acclimatization for temperatures vary within the province, within the region as well. So this is something very important, which calls for community by community analysis. Going further, what do we do next, and what's next with CanAwesome? The first thing that comes to our mind is the retraining of CanAwesome with the 2023 data. Tools like CanAwesome need to be retrained either with new data annually or after any wildfire season, which is true in both cases when we think upon 2023. This is a graph that I obtained from CIFC, which, to put this into context, between 2010 and 2022, the study period that CanAwesome was working with, about 35 million hectares of area was burnt in Canada. So far, in 2023 alone, 18.5 million hectares of area has been already burned, which is about half the area that was burned in the preceding 13 years. Interestingly, though, the total number of annual wildfires is declining. However, the intensity seems to be on a steep rise, especially given climate change. So again, within this figure, as you can see as well, they had to redo their entire y-axis. So that's how I'm hypothesizing. When we start looking at the community exposures, we'll have to probably rescale the things around there as well. So if we narrow down over BC, again, this table shows a comparison of the worst wildfire seasons in British Columbia on record as of December 1st, 2023. The record was originally set in 2017 when about 1.22 million of hectares of area was burned, which was quickly surpassed in 2018. And now we have about, I would say, 3 more weeks to go in 2023. And more than twice as much area has been burnt already. There are still active wildfires in BC, which are either out of control or which are still being held or are still burning. So in kind of like a conclusion, this is what, again, I obtained from CIFC. And one thing is for sure, that biomass smoke exposure is here to stay. This figure that this screen grab that I got was from December 2nd, 2023, and there are still 155 active wildfires in BC. And this is a well-known fact that biomass smoke exposures will intensify and increase in frequency over time. And models such as CanAwesome can provide an important window into the past that can help us quantify and reflect of what went right and what went wrong, and most importantly, help us prepare for what's to come in the very near future, especially thinking in terms of public health and the exposures. So with that, I'd like to thank the entire team at Environmental Health Services and Health Canada for funding this study. And especially, I would also like to thank Dave from Health Canada, who has always provided us a very good feedback from the Health Canada side of things. A huge shout out to Celine and Yazan from ECCC, Environment and Climate Change Canada, who have helped us get a lot of data into our systems. And we are very thankful for UBC for providing the computing facilities, as well as Compute Canada's CEDA system hosted by WestGrid, which we use for training all of our models and hosting our data for a bit. And yeah, please feel free to reach out to me. That's my email listed there. And you can also scan that QR code, which takes you to the original CanAwesome manuscript, which was published in Science of the Total Environment. And the same code basically can take you to the GitHub code repository if you're interested. So we are trying to bring in all of the code, making it publicly available, since we are using all of the publicly available data sources. And with that, I think I would stop talking. Again, thanks a lot for listening and tuning in. And over to you, Eric.
Thank you so much, Naman. Really great presentation. So I do have a few questions. Some of them I think you can answer fully, some of them maybe partially, but we can work through these, but some good questions. First of all, anonymous attendee says, great presentation. Any plans or ability with data to expand earlier than 2010? That's an interesting twist on. So yeah, so just remind people, 2010 to 2020 is the CanAwesome time frame. What about earlier time periods?
Well, that's a very good question. So since we are using a bunch of different satellite products, we want to make sure that we are able to get data for all of, like, during that entire period that we have. And for AOD data, especially, it's difficult to get them a little earlier for that period. And moving forward, one thing that we kind of got to know is that the Aqua and Terra satellites are being decommissioned, so they're gonna get out of orbit. So we are already thinking in terms of the next steps, because we'll need new satellite products to replace the old satellite products. So yeah, thinking about the hindcast scenario, looking at the previous years, there is a possibility, but uh, honestly, right at this point, we have no plans to kind of take it further back. What we are planning is how we can keep it going, and more importantly, kind of operationalize this model that it can be used. So moving from hindcast to a nowcast or a forecast, something like that.
Yeah, it makes a lot of sense. It's all contingent on data availability and data quality. Uh, I have a question from David Peterson. It's an interesting question. You're probably not empowered to totally answer the question, but so maybe you can give your opinion here. Given how there is no safe level of air pollution and that the World Health Organization lowered its guidelines in 2021, we will see CCME, will we see CCME and our BC Ministry of Environment lower the standards and objectives soon to align with the WHO guidelines or be even more stringent? What's your take on that? I'm sure you've thought about it.
Right. Yeah, like so what we know right now is CCMA at least will bring down the Canadian ambient air quality standards to match that of BC's. So we are looking at, that's why I left that particular column empty for 2025. They might bring it down to 25 micrograms per cubic meter for 2025 for the daily exposure level, and about 8 for the annual exposure level. But yeah, like you pointed out correctly, there's like no safe value, that no safe concentration, or I guess like if all sorts of exposures are bad exposures or smoke exposures. But yeah, that's all I know right now. I don't know if they would make it more stringent, especially the way things move.
Well, maybe we need a machine learning model to predict what are the relative health effects of different thresholds, but
yeah.
Outside of your scope. But a good question nonetheless. So I have a question from Morgan Fraser. Is there a way to, apologies for the background noise, by the way, but Morgan Fraser asks, is there a way to make a distinction for residential wood smoke between in-home wood stove burning versus heat, or for heat, versus open burning to get rid of yard waste? The reason why this question is being asked is their community is considering a proposal to create alternatives for open burning, and they're looking for specific sources for the air quality issues related to open burn. So the distinction between burning for heat, which is very difficult to regulate, versus open burning, which is more potentially more amenable to regulation.
Yeah, that's a very, very good question. And when we originally decided to develop CanAwesome, the one thing that we wanted to optimize the model was for wildfire smoke. And that is what we have done with this particular model. However, given that the time series that we use spans the entire duration of the year, that actually gave us the very first window to actually start looking at what biomass smoke exposures that were happening apart from the wildfire season only. So recognizing what sources of heat are being used in a particular community is a whole different, I would say it's a whole different problem and a whole different issue. But I guess with our model, at least we can identify where these exposures are happening, so that can help us kind of narrow down where the efforts of the folks who are in the decision making can focus on. Like, okay, maybe we need a small air quality sensor or something like that that could actually measure it. And then we can basically learn and listen from what that community is listening. What that community is doing to heat their entire residences, and then kind of like have like a feedback loop of like how that can be improved over time. So yeah, that I would say would be the best use case. with CanOSM.
Yeah, Naman, I appreciate you bringing up the use of low-cost sensors to get the hyper-local information. Even a CanOSM grid cell, which is 5x5, would probably not be able to
Pinpoint.
accurately, precisely pinpoint
Yeah.
these open burning scenarios. So there's an issue of spatial scale that may be mismatched with that problem. And this inability to disentangle, well, is it open burning versus residential burning? It all ends up being biomass burning, and so it all kind of gets lumped together. I have an interesting question from Sue Brooks here. Again, you could probably answer this in partial or total if you're empowered to do so. What is the history of the categorization of biomass smoke historically?
So the history of what? The category.
Here, I'll ask the question in total. So historically, how has biomass been categorized? And historically, have we identified, let me say this again. What is the history on the categorization of biomass smoke? And historically, we have identified emissions by more specific sources, open burning, which includes wildfire risk and reduction strategies versus residential wood heat. Is this a new trend or just served your purpose here? So I'm struggling to fully comprehend the question. Maybe if it could be rewritten. But what I'm trying to basically, how do you define biomass smoke in the context of CanOSM, and what is the importance of that type of definition?
Yeah, that's interesting. So yeah, definitely not just to serve our purpose. When we started working on this, I guess, again, wildfire smoke was the biggest concern that usually throws people off when people, especially in the East Coast, how they basically reacted to the smoke plumes drifting from wildfires in Quebec and Ontario, who have not really seen that much smoke. People were freaking out in New York, for instance, what we are very much used to on the West Coast. So sure, wildfire smoke is like more recognizable by people, but what's more important are these prolonged exposures. So like if a community is being exposed to a bad wildfire season, at the same time, the temperature drops in the winter, there's wood heating that's happening and that smoke's being trapped and people are being exposed to it. So that's a very long period. So usually all the studies are focused on the short-term exposures. Sure, the admission to ERs went up, salbutamol dispensations or asthma visits went up during a wildfire smoke event. However, we need to look at the bigger picture of if that particular community was exposed year upon year, season upon season, and things like that. So I guess that kind of answers the question as best as I can. Oh, you're on mute, Eric, sorry.
Thank you for that, Naman. There's an interesting question here, and it's important to some of what you were talking about in terms of identifying communities disproportionately impacted. What definition is a First Nations community? Is a place like Burns Lake, how is that characterized or as it relates to First Nations? Is it by population? Does it incorporate borders? Are inner city communities reflected in this Indigenous community definition? How did you come to that presentation of Indigenous communities?
Okay, so yeah, that's a good question. So Indigenous communities, when we talk about Indigenous communities, these are federally registered Indigenous communities. So they could include the First Nations, the Métis, and the Inuit. So we are looking at a pan-Canada level. So we looked at all three Indigenous groups in Canada. So the pink dots that were on those maps, those are the actual government-provided Indigenous communities, and all of these data are publicly available. When you talk about Burns Lake, so when we say disproportionately impacted, these are remote communities. So as you saw with the NAPS monitoring stations, these are usually located in places where you have higher population living, which are like sort of urban centers, or you have they have had bad air quality. When we start moving away, however, it's not like the wildfire just disappeared. The wildfire exposures are happening, but there's no way for us to know that those exposures have happened. And that's when CanAwesome kind of fills in that gap of like, okay, there's a station located 300 kilometers away, but we want to know if this particular community was impacted. And the only way to do that is use this information, use all of the satellite observations that have happened over the time, averaged out, and then you kind of look at that community. So yeah, indigenous communities are specifically looking at the First Nations, the Métis, and Inuit settlements that are across Canada. And then when we talk about disproportionate impacts, those are specifically for remote communities, which are at a certain distance or which have no monitoring stations nearby.
Thank you for that. I have an important question or comment and a question from Amber Bay. As a parent of a child that lost his life in July from an asthma attack exacerbated by wildfire smoke, we have spearheaded Carter's project with the BC Lung Foundation. So Amber's question is, where do you think would be the most needed areas in BC to have proper air quality monitoring systems first? In other words, which communities would you prioritize for maybe new air quality monitoring instruments to be deployed, and why?
Yeah,
Based on your kind of work and understanding of the problem.
Yeah, thank you for your question, Amber. And like you pointed out that there are certain communities where we are not in a position to tell if there have been high smoke exposures or it can happen over time. So our work with Health Canada was to provide them all of these data, supply them with these data, and they are the ones who will be picking up locations. So we have provided all of these maps. So what the maps that I showed they're all interactive. Well, what I showed were just static maps. So the maps that I have are actually, you can zoom in and click on different places and see what was the number of days that community was exposed, how high was the exposure level, and things like that. So we have provided all of the data to Health Canada. I think that is still beyond our purview of, we can only suggest that we can only provide them the data. They are the ones who will be making the decision at the end. But yes, we have recognized certain locations which are exposed to biomass smoke, not only during wildfires, but also in winter seasons. So I guess they are the ones who will actually be making the call. All we can do from our side is give them all of the data and all of the visualizations, and so they can make this data-based decision rather than going from anecdotal evidence, which what we have seen is kind of corroborating right now each other. So they are, what the people have seen and felt is kind of being, we can look at it like from a data perspective as well. Like, okay, this location was exposed last summer, or last summer was actually worse than this summer, and the winter was bad, things like that.
Yeah, quickly, I will plug something that you actually have worked on, which is BCAP, so the BC Air Pollution Prediction System. Can you just maybe inform people about that? This is a good opportunity because it does try to forecast in terms of which communities will be disproportionately impacted and what could be the, as you know, for vulnerable populations, those with asthma, you know.
I'm definitely gonna bring this up. So
I don't want to miss this opportunity just to kind of plug that resource for people who have children with asthma, and you know, how can they understand, is my community going to be impacted by poor air quality?
Yeah, so this is still loading. Let me just hit accept, and there we go. So this is the public facing site of the British Columbia asthma prediction system. And we are using an Environment Canada product, which is called Firework, which predicts PM 2.5 across Canada. And you can look at your local health area, and this is just for today. And you can basically click here, and It'll tell you what the concentrations can look like, how many salbutamol dispensations have happened over in the past, is the air quality good enough or not. So this is the air quality objective that we have and how it's going to look like. So this also is a public facing tool that people can use. We can also look at a particular date, for instance. Let's say we go to August 16th of this year when we knew there were smoke patterns. So yeah, here, let's say we click on the Kamloops Local Health Authority, give it a moment. And yeah, so here it says you had this excess, the air quality objective is right here, and you had these huge peaks of air pollution that have happened, or PM 2.5 measurements that occurred. So this is a good tool and as well for reference to get like some sense of how the situation is going to pan out. Also gives you, if you were to do it for today or tomorrow, it can actually forecast for the day and the day after. So let's say if I was to click for the Tri-Cities area, okay, give it a moment, it'll update, and it can also give you a forecast of how that's going to look like. So yeah.
Great. So a pretty straightforward question, Naman. What site is this information on? Some of what you presented on is publicly available. Some of it is unpublished. So can you just spell out for people, how can they access this information?
For sure. So it is called Canoe, the data portal itself. And let me just pop that link. The Canadian Urban Environmental Health Research Consortium. That was the reason I didn't remember. So you have the PM 2.5 estimates that are available at a postal code level across Canada. And I've just posted the link to that data repository, and you can access those data there.
Yeah, and so just to be clear, that's the output of the model that's trained for 2010 to 2019, all the daily PM 2.5 predictions at the postal code level that people can download and analyze, use for whatever purpose is needed.
Yeah.
So we are coming to a close here. So let's see if there's a question that I may have missed real quick. I think we've covered it all. So
I think we missed one.
Did we?
Can awesome data can be found? Is it mapped? Okay, it's mapped. Similar to firework, blue sky, fire smoke. So yeah, blue sky, firework, they are very different from Can awesome. Firework is more like a physical model, looks at even the dispersion. Blue sky is a completely different model, which is run at UBC. However, blue sky is only available during the wildfire seasons and not the entire year. Firework is the one which is now expanded for the entire year. So yeah.
Thank you, Naman. So it is 11 o'clock. I think we can close this session. I guess as we close, thank you very much, Naman, for the great presentation and providing information on those resources, publicly available resources. I will note that Naman's work is driving a lot of our research to understand the health impacts of air quality. So I myself am benefiting from his hard work, and hopefully whole of BC will benefit from this work in some shape or form. Before we sign off, I want to reiterate the BC Lung Foundation Air Quality Workshop is happening March 12th. There will be a save the date email sent out, and so look out for that, and don't forget to register when you see the link come live. So with that being said, I will go ahead and sign off and just thank everybody for attending and the great questions and the dialogue. I appreciate it.
Thank you, everyone. Take care.
Thank you.